Hello, I'm Cary Hulse. I'm an urban forester with Wetland Studies. We're a subsidiary of the Davy Company. My division, we deal primarily with development, design, tree preservation. So we're going to talk a little bit about that tonight. So first question I always ask is, well, why trees? Why are trees important to us in the realm of development? Well, so of course, I have to talk about the Y tree, the Y oak. Anybody recognize this? Has anybody seen it before it died? This was the largest white oak in the United States. They aged it at 460 years old. I think it fell in 2002. So there's a picture. You can see houses successfully around a tree for a really long time. And in stark contrast, anybody know where this is? This is Levittown. This was the first real planned subdivision, sort of the beginning of the American suburbia. But notice what's missing from this. This was a planned community. They bulldozed everything and built the whole thing very clearly with a plan, but the plan had no trees. But what's missing, obviously, is the trees. We put them back. Notice this is what it looks like now, well, or at least now when I put this PowerPoint together. But it didn't take very long for people to realize that the trees were missing and they wanted them back in their community. So here's some examples of what people consider sort of the ideal. This is, I think, St. Augustine, Florida. Those would be live oak trees. And interestingly, there's another one that's State College, Pennsylvania. Those are elm trees. Similar condition, but we want trees in our communities. We want trees in our streets. Obviously, all of the values that they add to our communities. So that begs the question, well, how can we build and still have trees? So in order to build with trees, we have to understand roots. Dr. Shigo once said, if someday we are to know everything there is to know about the above ground portion of the tree, we will still only know, does anybody know what the quote is? Half the whole story. Unfortunately, the vast majority of traditional arboriculture is focused on the above ground portion of the tree. And roots have always been something of an afterthought, but in development, they're what's key. So this is a graphic. This was from the Morton Arboretum, intended to depict what a typical field-grown natural root system should look like. There's a long-standing debate over what species of tree this is. Personally, I think it's a pecan. Rumor has it the artist wrote it into one of the branches somewhere, but I've never been able to find it. If you've ever been to the Fairfax County Urban Forest Management Division office, they used to have a full-size print of this on their wall. It's really cool. But the point is, look what the root system looks like compared to what the canopy looks like. And I imagine everybody's seen the picture, the graphics of the tree sort of mirrored upside down, where the roots mirror what the canopy looks like. And that's not realistic. This is much more realistic. So the question is, well, how do we know that? Well, we dug them up. These are some pictures from some of the actually, this was the first one, the Root Appreciation Day workshops that we've done. We've done several of them since then, where we've actually gone out, picked trees and dug up roots and measured and mapped and tried to understand what tree roots are really doing. In the pictures, you'll see the roots, after they're uncovered, are painted with chalk paint to make them visible in the pictures. They're not really bright orange, or in one of these other pictures, I think they're white, but I always get that question. But you can see that they're relatively shallow, not relatively shallow, they're very shallow. And they go a long ways away from the canopy of the tree. So here's an example. This is a Norway maple. It's only 12 inches in diameter, and it's got roots mapped out 36 feet from the trunk of the tree. And I think with some of these, it got to the point where the roots were so fine that we just couldn't follow them anymore, but they did keep going. And most of them are very shallow. The top few inches is pretty typical. Okay, come on, there we go. So here's that same maple tree with a 36-foot radius circle shown around it, and that's where its roots were. Here's another example, 30-inch hackberry, and this was a more compacted site, so the roots were slightly deeper, but still, we didn't find any roots deeper than about 18 inches. And the roots went out 76 feet. And again, we traced them out until they were nothing but little thin fibers, and it got to the point where we physically couldn't dig around them without just destroying them. We couldn't follow them any further, but they did keep going. So we need to think about construction and think about what the issue is. Obviously, the issue is root damage. It's the most significant problem with development. Roots can be damaged in so many ways on a typical construction site. They can be cut by utility trenching, grading, just general excavation. There's soil compaction from equipment and material staging, all manner of construction traffic, compaction from fill soil, and there's also the potential for chemical contamination, concrete washout. Just all of those typical construction activities have some impact on roots. So that begs the question, if we know what tree roots typically do, how much root damage can a tree withstand? How do we figure this out? And how do we get trees in the process, so to speak? But I always kind of throw this in, and let's not forget where trees came from, what they are used to, what they want. Trees don't really want to be near us. They don't want to be near our buildings. They don't want the crummy urban soils that we stick them in. This is what they want. And we try to put them in places like this. This is fun. Obviously, at least they tried to put up some fence that was an attempt to protect the trees. And the contractor maybe thought he was doing a real good job because the fence wasn't touching the tree. But really, if you look, you can see there's roots sticking out. Clearly, there was a pretty significant amount of root damage that occurred on this site with these trees, even the small ones. So here's another example, similar situation. They've got these existing trees. They dug down probably 10, 12 inches, put in stone, backfill, compacted it, and then poured their concrete. And remembering what that root system looks like, it's usually pretty shallow, the top 12 to 18 inches, generally not much more than that, if ever, and often much less than that. So a relatively shallow excavation, like for a sidewalk, you're only excavating 8, 10, 12 inches deep. A lot of contractors or engineers might say, oh, it's a shallow excavation, it shouldn't be a big deal. Well, as far as the tree is concerned, that's almost its whole root space. So even though it's a shallow excavation, it's still really significant in the terms of the tree's world. So this is a situation where these trees are not very happy. So here's what we do, right? The tree's in the way of the root of the activity. We want to put in a curb. So we go in, we cut the roots, and then what happens? Well, the tree falls down because we've severed the roots, and now the tree has no way to hold itself up. This is one of my favorite examples. I think this was Quantico. We were contracted to inventory the trees. Clearly, the base was interested in protecting trees. They wanted information about the trees. So we did a tree inventory for them. And then they refused to let us do any more. They put the trees on the plan as a dot. So clearly they cared enough about the trees to have an arborist look at the trees, but they didn't follow through. The tree died because it was nothing more than a dot on the plan, and there was no protection or management designed into the plan. And there was no arborists involved in the project outside of our original inventory, which happened long before the design. Interesting, if you can see, I know this is kind of dark, but the fellow walking by the tree and the ribbon on the tree, can you see the soil stain up the trunk of the tree? When they dug the hole for the foundation of that house, they had piled the soil all up around that tree, and it sat that way for probably 3 or 4 months while they built the structure. And then they put the soil all back, and the contractor, I'm sure, was real proud of himself because, by God, he didn't bunk the tree and knock some of the bark off, so it ought to be fine. Not so. That was only a few months after construction, and the tree was already starting to fade. And this is the reality. There is no tree wrench. You can't fix it. You get one shot at this. There's no way to go back from this condition. All too often, we arborists get called in on construction sites that are in this condition, and, hey, my tree is dying, can you fix it? And, you know, I pull this slide out and say, yeah, no, can't really do anything about that. You should have called me, you know, a year ago or 2 years ago when you were starting your design, and we had an opportunity to work through it. It's another favorite example of mine. Clearly, that entrance sign was designed with that tree in mind. I remember when they built it, the tree was gorgeous. It looked fabulous. A year or two later, this is what it looked like. So, how do we design with trees? Okay, move forward. Hey. So, in order to design with trees, we need to understand what root systems are doing, and we need a way to correlate that root system with a construction plan. And we can't usually afford to go out and dig up every tree and measure every root and map everything and survey everything. And I've worked on a few projects where we've gotten to do that, and it's really, really cool. But it's really expensive and really time consuming and really unusual, just because most development projects don't have that kind of time or money or even desire. They want to save trees, but not that much. So we need a rule of thumb. We need some general guidelines to work with. So one of the big ones that we use is this concept of critical root zone. And the critical root zone is defined as a portion of the root system that is sort of the minimum necessary to maintain the health of the tree. Notice I said the portion of and minimum necessary. Remember the Morton Arboretum picture, the drawing that we saw? The roots go way out. The critical root zone is just a portion of that larger root zone that is necessary for the tree's survival. So again, without digging up every tree and mapping everything, we have to have a rule of thumb to determine what this critical root zone is. And most of my colleagues, we subscribe to this concept of 1.5 feet of radius per inch of diameter. When we say DBH, we're talking diameter at breast height, 4.5 feet above the ground. And that is the rule of thumb that we use generally. So different folks, different municipalities, different arborists, different designers, not always arborists, just landscape architects, designers, and so forth, might argue Well, why 1.5 feet of radius? Why not 1 foot of radius? Why not 2 feet of radius? Well, long story short, 1.5 feet of radius works out to be a little bit conservative and reasonable and effective. A lot of municipalities actually dictate a 1 foot radius. I've had other municipalities dictate all kinds of crazy formulas that you have no idea where they're getting it from. There's quite a bit of research out there that somewhere between 1.25 and 1.5 is about right. Me personally, I like 1.5. It's a little more conservative. I think the Kim Coder documentation uses 1.25 as the go-to. But anyway, here's an example of why it matters. So the drawing here just shows a proposed building and some proposed utilities and a box around the tree representing the area that we can keep. This is the area that we have to protect because we're doing all this work. This is what's left. If we draw the critical root zone at 1 foot of radius, we can look at this and feel real good about ourselves. Oh, well, we're only impacting maybe 10% of the root zone, of the critical root zone. And with 10% impact, we can be pretty confident that that tree will survive that impact with some moderate or even minor mitigation measures. So we would propose some root pruning, some fencing, maybe a little mulch, and she should be good. But, come on, move forward. What if we draw it at a 2-to-1? So this is 2 feet of radius per inch of diameter. Now, do we feel very good about that tree's prospects? No. If we think this is more accurate as far as what the root zone really does and its critical root zone needs to be, then we're anticipating 60 or 70% of its root zone being disturbed. And at that point, you might have years of mitigation, and even with years of mitigation, stress reduction measures and care and handing that way, it still is not likely to survive. So we like to look at, like I said, that 1.5 feet of radius per inch of diameter as a good, reasonable rule of thumb. So a little example. This is a site in Anne Arundel County. This was I think it was like an Alzheimer's care facility. But it was originally a historic farmstead, and you can see, I don't know if I move my mouse, will you be able to see it? This is the existing house, and these trees were around the existing house. And so the design team decided, oh, these trees are in nice condition, they look good, and we want to try to keep them as part of our entryway into this new facility. It'll be great. So this was their original plan, and the trees are those little generic tree blobs that are not scaled in any way. They don't really mean anything. They could be fire hydrants, they could be light poles, they could be wells or any number of other things. It doesn't tell you much. Okay, we can presume that that's probably a tree, but is that a little tiny tree? Is it a big tree? What is that? It doesn't tell me much. So one thing I always like to mention at this point really is the locations of these trees, especially big trees. The location is critical. And unfortunately, all too often with tree inventories are very often done with GPS that's not survey grade, but what we would call natural resource grade or even consumer grade GPS. There's a lot of apps out there. You can take your phone and inventory the trees on your property using the GPS on your phone or any other type of handheld GPS unit. Those units might seem accurate and they might claim to be, ooh, sub-meter or whatever. But in reality, if they're not survey grade, they're probably plus or minus 10 meters. They might be perfectly on, but you have no way of knowing that. You could be 30 feet off. And if you're off even by 3 feet in a design, that could be the difference of the tree being next to the sidewalk or in the middle of the sidewalk. So having the trees truly surveyed as a part of the design process is really critical. So back to our little example here. Here we've taken those original tree blobs and scaled correctly the critical root zones in and shaded out in like sort of a pink color where the impact to those root zones are. So now the trees are more of a design element. We're understanding better what the design is doing to the trees, how the trees and the design are interacting. And this is actually what it looks like. The trees did very well, made for a neat site. The other thing that we consider in addition to this concept of critical root zone is structural critical root zone, where this is a much smaller circle around the tree that represents its most significant structural root plate. Meaning if we disturb anything in there, we cause any root damage in that little tiny circle, even if it's relatively minor, it could mean the tree becomes unstable. Not necessarily that the tree is going to die, because the overall impact could be still pretty small. But if we have damage to roots within this zone, we run the risk of the tree becoming unstable. And I always tell my clients, well, it doesn't matter how green the tree is if it's horizontal. That doesn't help us. Of what sort of our typical plan graphics look like, where we take the project plans, the design, and the survey, and then we overlay our tree information at scale on the plans. So this one is a really huge, absolutely gorgeous beech tree. And you can see the small structural root zone around the base of the tree. You can see the canopy sort of drip line, and that's just an average radius. It's a circle. It's not exactly the canopy, but it is an average radius of the canopy. And then the critical root zone using that 1.5 feet of radius per inch of diameter rule of thumb. So I think I mentioned this before, a little bit about municipal requirements. Municipalities do all kinds of crazy things. Different people means different interpretations, different priorities, different agendas, and every municipality has different people. So you can figure out where that goes. You go to different places and there's very different focuses, is that the right word? On different things. So for example, in Fairfax County and Arlington, they both have requirements for canopy credits. There are other places where you have specific requirements for tree replacement that's counted by individual trees and not just overall canopy. There are places where their requirements don't look at individual trees at all. They simply look at how much tree canopy you have on the site and how much you're preserving, but not looking at any individual trees at all. Loudoun County, for example, is like that, where they don't really care about what any one specific tree is doing. They want to look at big picture, canopy of the whole sort of forest preservation. The Maryland forest conservation laws is very similar to that. They don't really look at individual trees so much as overall forest. The flip side is if you go to, say, Palo Alto, California, for example, oak trees, specifically oak trees, native oak trees, might as well be made of gold. Doesn't matter how big they are, you can't touch them. Actually, I think it's 6 inches, but you can imagine that if you've got a project plan and there happens to be a 6.5-inch oak tree on your project, that oak tree can stop your project. It's pretty impressive the way their ordinance is designed around the protection and preservation of their native oak trees. If you've got other species, doesn't matter how big they are, they generally don't care about them. The point is that the requirements vary wildly depending on where you go. So a little bit about protection measures. What do we do once we've got the trees on the plan? How do we design a protection strategy? So we've designed using the critical root zone. We've helped the design team move things around. We now need to protect the trees. So at a bare minimum, we generally require some sort of fencing. Most municipal requirements will have some requirement for this. We recommend at a minimum a 4-foot welded wire. Some municipalities require chain link. Some don't have any real requirements other than that you have something. I've seen some places where they use barbed wire or just a wooden board on posts. But generally, like I said, we recommend a 4-foot welded wire at a minimum, and it needs to have signs on it so that both the public and the contractor and anybody around the site understands why it's there, so they don't feel like, oh, well, this is in my way, let me move it. Here's a good example of a fairly small tree with a good protection zone around it. Sadly, the last time I looked at Google Earth, this tree was no longer there. This is a project in Princeton, New Jersey. It was a graduate housing facility that was being renovated. One of the other more common basic treatments is root pruning. Root pruning can be done in a number of ways. The simplest is mechanical root pruning, where they might use a chain trencher like you would use to put in a utility, or in this case, this is a rock saw type saw. It's a circular saw with teeth that look kind of like stump grinder teeth, and it can actually cut right through pavement and such, and it works really well. But the idea behind root pruning is not to protect roots, it's to cut them off intentionally. But to cut them off intentionally and with some measure of control. If we draw a line in the sand and let the contractor go to town, the contractor is going to go in with an excavator and start digging. And what happens is any roots that are coming into that area where the excavator is digging, the excavator is pulling to the side, and the roots tend to get torn and broken. So instead of having the roots cut methodically and in one known spot, they tend to get broken and smashed and frayed, and that type of damage is much harder for the tree to deal with than a relatively clean and controlled cut. Now, a chain trencher or this rock saw is still not as clean a cut as you would get if you went in there with a chainsaw or a handsaw or pruners, which sometimes we do. If it's a critical location or a critical tree, we might prescribe where we would excavate with an air tool or by hand and actually physically cut the roots using those kinds of hand tools or a chainsaw, or I've used even sawzalls and things like that to get as clean a cut as we possibly can to minimize the stress that cut puts on the tree. But again, most development is not looking to spend a ton of money on preservation. They're trying to balance tree preservation with all of the other things that go into development. So when you're looking at a large development site, no one tree really matters that much. What matters is that they have a reasonable effort on a lot of trees. So doing these kinds of treatments becomes sort of the standard go-to approach, where we prescribe fencing, root pruning, and then mulch is the other thing. Oh, well, here's an example of what the root prune line looked like. This was also that site in Princeton. The building on the right is scheduled for demolition, but they wanted to save all the trees in that little grove. So we had the line in the sand. This is where the construction is, and this is where the construction is not. So we cut our root prune line there, and then we put the fence up on the same location, and the contractor could go and do their work. And then we had no issues beyond that. So here's just what typical construction details. This is what would actually go on the construction plans for the contractor to install. And I mentioned mulch. Mulch is probably the single simplest and most valuable thing we can do for trees as a stress reduction measure. Trees and turf don't like each other. So if we can put down mulch, we can minimize the competition that trees and grasses have by removing the grasses and providing mulch. The mulch sort of mimics that traditional forested condition where the leaves are falling and decomposing and you've got nice organic material there for the tree roots. That's what the trees want. Remember the picture of the mountains and the trees. Picture the understory of those trees. That wouldn't have been grass. It would be leaf litter on the ground. That mulch mimics that condition. The other thing that mulch can do, especially on a development site, is help manage soil moisture. So if we go and we've got a construction site and that limits of disturbance line, that line in the sand, we know we're going to lose all the roots over here, but if we cut off all the roots where we know we're going to lose them, but then do everything we can to protect what's left, by putting some mulch down in that zone, right where the roots are cut and then back into where they're preserved, helps to manage the soil moisture, which further reduces the stress to the tree. So if nothing else, mulch. And here's an example when we do this on large scale. We actually use contractors that can bring in a blower truck. They bring in a tractor trailer full of mulch and they let these hoses and they can put the stuff down really quick, and they don't have to go in there with heavy equipment to do it. These two guys just drag those hoses through the woods, and it's very minimal impact to what you're trying to protect, as opposed to going in with, you know, maybe a little skid load or a bobcat or something like that and putting down the mulch and then moving it around. Well, now you're putting a piece of machinery in there that has compaction implications and further problems. They might run into the trees or, you know, unintentionally bump into them and so on. So especially on a large site, having the mulch blown in is a really great option. So there's some other really cool things we can do, kind of think outside the box, to provide additional protection to tree roots on construction sites where sort of historically they might not be able to be protected. So this is an example of what a temporary staging area or a temporary construction access road might look like. And this is what it looks like in reality. This was a site up in Bryn Mawr, PA, where they were renovating a home, and I believe they were bringing in a lot of stone material, slate roofing and stone for building construction. And they needed a fairly large area to store this material while they were doing the home renovation. But you can see that grove of trees around the house. We wouldn't want them to just go in there and stockpile stone in and around these trees. They were moving it around with equipment and so forth. So we designed this temporary protection zone, and it was actually very similar to this design, where there's mulch and a matting material that provides some separation and protection to the tree roots to help minimize the soil compaction during the staging process. And then when it was all done, this was all taken away and it was put back the way it was. But the process minimized, or this design minimized the soil compaction that would have been as a result of that staging material. So what if the impact is a permanent condition and we want to try to save roots under a permanent new structure? So here's an example of what we call root aeration matting, where we would put this down at the beginning of the project before they bring in any fill material. And instead of root pruning at the limits of disturbance, we are able to use this material to put the fill on and move the root cut further away from the tree. So in this picture, you can see the fence material on the right is silt fence, and normal construction practices, we would have cut a root prune trench along that fence line. But if we did that, obviously then that really nice oak tree there would have been removed as a result of the construction. In this case, this is a proposed roadway. I don't remember what the facility is. I think this is one in Loudoun County, but the roadway was to be built up much higher than this location. So they had to bring in a lot of fill material and build it up to build their road. But what we did then is instead of root pruning behind the tree at the actual limits of disturbance, we root pruned out where the black matting stops. And then we did, come on. Why are you not going forward? There we go. And what we actually did was installed these little timber walls to hold the fill material off the trunk of the tree. And then the matting material provided a separation between the fill and the existing tree roots underneath. The matting material actually has a rigid core and has air and water flow capabilities. So it provides air and moisture to tree roots that are underneath it, and it helps minimize the soil compaction of the fill material on top. Personally, I've seen this work. I know it works. Personally, I think it doesn't protect the roots permanently. Those roots are going to want to come up to the surface because the roots want to be near the surface. What I think the material really does is buy the tree time. If you think about it, trees don't function on the same sort of time scale that we humans do. I think it was Kim Coder that said, you know, trees don't function the way we do. They live on a different time scale. Trees grow up for 100 years, they rest for 100 years, and then they die for 100 years. Most of the things that we do happens now. So we go in and we do construction, the impact is now. And the tree can't handle that fast change in condition. What the matting material does is help slow the reaction to let the tree deal with the fill material slowly. And trees can overcome slow changes in their condition. They can't overcome fast changes in their condition. If we were to do this fill material without the matting, that tree would be dead within a couple of years. Yeah. So the question was, are the roots going to work their way up through the soil to the surface? Well, think about this. The reality is the tree's roots are down at this level, and we've saved all of the roots out to where we've cut them off. So the roots underneath the matting are still there. That tree will eventually start to put roots up through the matting material and work their way up towards the surface. Yes, that is a long-term situation. That doesn't happen overnight. And the matting material will last for many years. So it takes a long time for the matting material to break down. It takes a long time for the tree roots to work their way up through it, but they definitely will. Does that answer your question? Okay. But that's the whole concept here, is that we're buying the tree time to adjust to its condition. So how are we on time? Oh, we're flying right along. So here's an example project. This was a project in Maryland where there was a couple of very large trees adjacent to an existing house, and they were proposing to do some additions. This picture, you can see how close the tree is to the house. You can see how large the tree is. And in the foreground there, you can start to see some of the markings on the ground where they were considering placing structures. And you can imagine that that's well within that tree's critical root zone, probably within its structural root zone. So this was one of the rare conditions or rare projects where we actually got the opportunity to go out there and dig up the roots and figure out exactly what was going on, and then work with the design team, the architect and the engineer, to massage the design of the project to minimize the root damage and work around the tree as best we could. So there's an idea of what the site looked like. And here is where we have done some root pruning, and we've also provided some temporary root protection matting. You can see the fencing material. The root protection matting, the orange matting, is intended, again, that's a temporary condition like the staging area, only in this case it was really meant just to protect the tree roots from the construction, the contractors' workers, from essentially just their foot traffic and wheelbarrows and things like that. You'd be surprised how much soil compaction just foot traffic can cause. But the matting material helps to mitigate that so that they can go in and build what they need to build and still have those roots survive that condition, or survive that activity. So the other thing that was interesting here is we knew that if they were to go in and build using a traditional footing and foundation wall type construction, there would be no way to do this successfully and preserve the tree. So the solution was to design the structure with pier and grade beam and a fully supported floor, so that there was space between the piers where tree roots could be left alone and left to survive underneath the new structure. So again, that's more pictures of the pier locations mapped out and the tree. And so here was the process for excavating the pier holes. The red thing that you see there in the pictures, what is it called? Utility vac. We always called it the supersonic shop vac, where this thing gets connected up to a big commercial industrial air compressor, and they use the air tool to blast the soil out of the way and loosen the soil all up, and then they use the supersonic shop vac to suck the soil out of the hole. And in doing that, they were able to gently get all of the soil away from the tree roots. So once they opened up these holes, we were able to field adjust the pier locations. We had to prune some roots, but we didn't prune all of the roots. And we were able to adjust the location of the pier so that we didn't have to prune the biggest roots. So you can see in this picture, there's a really large root, and there's a bunch of smaller ones. We probably cut many of the small ones to accommodate the pier, but we were able to shift the pier around to avoid the largest roots. And because we're doing piers, there's space between the piers where we didn't impact any roots. You know, personally, I don't think so. I'm sorry. The question was, how long can you leave roots exposed? Is there a time limit? And I've heard different arguments on that. Some specifications require wrapping the roots with burlap and then moistening them and wrapping them with plastic and all of this and that. Personally, I don't think leaving a tree root exposed is significantly detrimental, maybe is a polite way to say it, or the correct way to say it. If you think about it, everybody's seen tree roots that are surface roots. Everybody's seen a stream bank that's been eroded where tree roots are exposed. They're still healthy. They have bark on them. Bark does its job. And, just like the bark on the trunk of the tree protects the viable tissue below it, the bark on the roots will do the same thing. That's, again, I'm not pointing at any specific research or study that says that. That's just my own sort of anecdotal experience that I don't think it would be a huge detriment to leave them exposed for at least the duration of a construction project where it's, this would have only been open for, days or a week, maybe a couple of weeks at the very most, if that helps. So that's my philosophy, if nothing more. So here's just some pictures of the new work going up, and you can see the piers. And yeah.
Someone has said there appears to be hair roots in the picture. I'm gonna unmute myself. There appears to be hair roots in the picture. How will the tree get enough moisture when the building is built over a large amount of the roots?
So the building wasn't built over a large portion of its roots, if that answers the question. So yes, the building is going to cover up some of the roots, and so some of the roots underneath the building are not going to receive as much moisture as they probably did prior. But let me get to why this thing stops moving forward. In this picture, where's my mouse? You can see, this is a relatively modest addition, relatively small footprint compared to the size of the critical root zone of that tree. So, like I said, the construction activity was well within, even for a tree of this size, even within the structural root zone. If we were to do this using traditional methods, that tree would have zero chance of survival, or nearly so. And actually, it would have been likely to just fall over and hurt somebody. This method allowed us to preserve not only the roots under the structure, but the roots beyond it. So this tree's root zone goes way out in the yard in all directions on the other side of this new structure as well. So because we didn't sever the roots for the new foundation, those roots that we worked around were able to keep going and go out the other side. So yes, there's an area underneath the footprint of the building that's going to have a little less moisture, but all of the rest of the roots are still there. So just like I said with the root protection or the root aeration matting, where trees can handle change that comes slowly. So it is entirely probable, in my mind, that the fine fibrous roots, those absorbing roots that are directly underneath this structure, will probably slowly die off as that soil dries out some. But the larger roots that connect from one side of the structure to the other are still there and still able to do their thing. So once the tree roots are outside that new structure, they can continue to grow, and the fine fibrous roots that are out there are able to do their thing and still function properly. Again, slow changes that are well thought out, trees can handle. So sure, this is going to have an impact on the tree, no doubt. But the question is it mitigated well enough that the tree can survive that impact? That's the key question. All right. So, shift gears a little bit and talk about utilities. Utilities are the other big factor with development. We can't have our society as we know it without utilities. Utilities are sometimes above ground and sometimes below ground. The above ground utilities, unfortunately, are the ones that are the most visible. And we can end up with these kind of ugly conditions. But the reality is, pruning like this to prune around above ground utilities is correct. It's better than the alternative of topping the tree and then having the tree grow back fast. This kind of pruning can be sustained and actually maintain the tree much better. Now, what would be better yet is, the right tree in the right place. I'll talk about that a little more in a second. This is another example of the same kind of pruning. This is a tree with a good shape. With a little bit of pruning, that utility can be maintained without destroying the structure of that tree. And like I said, right tree in right place. Sometimes we don't have a choice. The utility is where it is, the tree is where it is, and we have to deal with it. But if we're designing, we want to design and plant new trees that are appropriate for the space. So we wouldn't put trees that are going to grow big in a space where they can't. So, we would put small trees underneath power lines and so on. There's another example, sort of an extreme example of utility pruning, but as ugly as that looks, that's a whole lot better than the alternative of having the tree be topped every year. But I want to talk about underground stuff because I like roots. And again, in my world, we deal with construction and design. We're almost exclusively dealing with tree roots. So here's an example of a simple utility. I'm not sure if that's a stormwater drain or something like that, but it's a relatively small utility in a relatively small trench, and most contractors or designers might look at that and go, that's nothing, that's not a big concern. But if you look really closely, you can see that there are an awful lot of roots in that picture. And yes, I stole these pictures off some random website. So there's another picture looking the other direction. You can see even more roots in the soil pile, and you can see the trunk of the tree that they came from. Again, really shallow trench, not very wide, not very deep, but boy, that's an awful lot of roots that got tore up in the process. That's what the tree looked like. So you can imagine how big the critical root zone of that tree must have been. And frankly, you can think in this picture, it's probably within the structural root zone. It's entirely possible that this kind of activity, as minor as it seems, could turn into a really significant structural problem for that tree over time as those roots that are damaged now start to decay. Fast forward 3, 5, 10 years, and that tree now has significant root decay within its structural root plate and is now prone to, being blown over in a moderate wind potentially. This way, there we go. So again, how far away should that trench have been? If we're looking at the critical root zone of this tree, I don't know how big the tree is. If it's, 30 inches or more, that trench should have been 40, 50 feet away to minimize the impact to the structure or the critical root zone. But, this is a little suburban lot. They probably don't have enough space to really move the utility that far away. So there's other ways we can deal with that. So there's the supersonic shop vac again. And this is one method where we can use the air tool, excavate. We still have to prune some small roots, but we can excavate around the larger ones and sort of meander our utility in there. There's some more examples of the same kind of activity where we've done the excavation with an air tool and placed the conduit. I think this was lighting conduits, electrical conduits at the Pennsylvania State Capitol Park facility. But you can see the amount of roots that are in that. And this was a park setting, and there were trees everywhere. And of course, being the State Capitol Park, there was no room for error. We were told flat out, well, we need to keep all the trees. So we were tasked with coming up with construction methods and protection measures that they had to deal with. So the contractors weren't super happy with it, but the end result was the trees survived and the client was happy. So there's a few other ways we can deal with it, depending on what type of utility it is. So a lot of either pressurized utilities, things like domestic water service, things like that, gas, natural gas, or dry utilities like electrical conduits or telecom, things like that, can very frequently be installed using directional boring. And this stuff is fascinating. The technology that they can sit that little machine down and use sections of pipe and push it in the ground one section at a time, but steer the thing all over the place. They can steer it wherever they want. Now, thinking back to that Morton Arboretum poster with the root zone, we know that tree roots are fairly shallow, and most utilities want to be deeper than that. So if the design team says, well, okay, my water line needs to be below the frost line, and that's 42 inches, and I can say, well, the tree's roots probably don't go that deep, or if they do, very few roots are down that deep. So if they can install their utility using this kind of technology, as long as any excavations that they need to make to connect it are outside the critical root zone of the tree, there's essentially no impact to the root zone. We can drill underneath the tree and avoid that impact almost entirely. So there's the comparison. If we put the trench in, we put the utility in a traditional trench where we open trench, dig a trench, put the utility in and backfill it, we're going to cut off all of those roots. But if we drill underneath the tree, we can sort of sneak underneath there and the tree doesn't even know we're there. So what about those types of utilities that can't be directional bored? So things like gravity sewers and storm drains and sanitary sewers that are gravity very often can't be directional bored. Or if they can, they're just not, well, directional bored, yeah, no, you can't really do directional boring with gravity. Or, like I said, it's just so large that boring is not really an option. It's just too cost prohibitive. You're in this condition of an open trench. So now the impact from this kind of construction is pretty substantial. So let's talk about an example project. This is New Haven, Connecticut. Traditional sewer system in the town. It was a combined sewer system. If I remember correctly, it was a 60-inch brick combined sewer where the sanitary and the stormwater were all in the same pipe. The pipe was installed in the 1800s. It was my cheat notes actually say 60-inch brick. It was hand-laid brick, built in the 1800s. They built the road on top of it, and it's been there ever since. This was still in service up until, I don't remember what year this was, certainly within the last 10 years. But their project was, the city had grown up to the point where they've exceeded the capacity of this combined sewer. So their project was to separate the sanitary from the storm. They were going to keep the original combined brick sewer and dedicate it to stormwater and add new sanitary, dedicated sanitary sewers that were separate. So project moves forward, engineers design it, and somebody raises their hand and says, wait a minute, what about our trees? This is New Haven, Connecticut, right near the Yale campus. So you can imagine there's some people there who might care. And you can see there's some trees that are worth caring about, some pretty colossal sycamore trees. So the engineer says, well, all of our excavation is in the street. The trees are over there. Street's over here where our pipe is. What's the problem? And somebody said, well, wait a minute. That tree's been there longer than the street, or at least as long as the street. The tree's got to have roots somewhere. There's got to be roots in the street. So this became this argument now, well, okay, well, how do you know if there's roots in the street? If we dig up the street, are we going to hurt the tree? Well, the solution to that was ground penetrating radar. They wouldn't let us dig up the street and look for roots. So we used the ground penetrating radar to look for roots through the street. So we set up a scan line and actually ran radar scans through the pavement. And we have a question?
Where do these trees, how getting enough moisture? Where are they getting moisture from? If all that's pavement.
I have no idea. It's fascinating to me how trees survive in these kinds of conditions. If we go back a page, you can see that there's a little bit of turf off to the right there, and there's a little bit of room around the tree. But these are old streets, and these trees have been there a long time. There are storm drains and downspouts from the houses. I would speculate that these trees have roots that have infiltrated some of the storm drain structures and have gotten down deep enough where there might be moisture in the soil. There's got to be moisture there somewhere that they're finding. Now, the other piece of that is these species. These are sycamore trees mostly, but very often we find that the trees that do the best as street trees are oftentimes the trees that do the best in sort of wet sites, wetland, sort of bottomland species. So trees like sycamore, ash before the emerald ash borer became a problem. I'm sure there are other ones, pin oak, for example, that they tend to do very well. Red maple's another one. They tend to do very well in these situations where their roots are compacted. I'm not entirely sure why that is, if it's a function of being tolerant of low oxygen because of the, in a wetland condition, if the roots are inundated with water, there's low oxygen. If they're in this streetscape setting, it's probably very similar because of all of the infrastructure covering the soil. It would equate to, I believe, a low oxygen condition. But that's a total tangent. But as far as where the trees are getting moisture, I can't say. But obviously they are, because trees survive in this condition. Some do and some don't. So maybe there are sites that they're able to find moisture and some sites where they're not. But the reality is, in this particular case, the question was whether or not we can dig up the street and have the trees survive. So we move forward with the radar scans. The host would like me to unmute. No. So here's an example of how we scanned. We laid out the scan lines in the street, and we ran the radar over it. This is a friend of mine, Cary up in New York. He there was a reporter came out to the site while they were doing this. This was kind of a big deal, and the guy that worked with him coined the phrase that the buggy there, that the radar unit, the antenna sits in that little tub in the bottom, and the control unit up top, and it looks like a baby carriage. So the fellow that works with Cary there kind of coined the phrase that was the ugly baby. And of course, that's what got printed in the newspaper. Cary he's still not happy about that, but and Cary looks like Grizzly Adams now. He's got a hell of a beard. Anyway, I digress. But so we scanned this and laid it all out, and then took the scan data and overlaid it with the site survey and the design. And you can see our tree symbology there. I've zoomed in quite a lot in this case, and these are fairly large trees, so it's hard to see. If I can find my cursor. Where's my cursor? There we go. There's a critical root zone circle here from this tree. The critical root zone for this tree is actually way the hell over here. But you can see each one of those little blue dots is actually a root detection, where the radar equipment saw a root under the pavement. So we could demonstrate pretty clearly that there's a lot of roots in the street. So if we do a traditional open trench here, we're going to have some pretty substantial root damage. So back to the drawing board, we worked with the engineering team on this and came up with the solution of doing what's called jack and bore, where they, instead of using a directional boring machine where they sit on the surface and they drill down and they tell it where to go, jack and bore, they actually dig pits and put a horizontal jacking structure machine in the pit and level it and get it all aligned just right. And then they bore and push the pipe into these holes. And then on the other end, there would be a receiving pit where they have the thing push and it pushes all the way through, and then they reset and they do the next section and so on. We did almost that whole street this way. And the result was, I actually just talked to my friend, Alan, who lives in Connecticut. He was the fellow from our team who was local to the project and did all the field work for us. He said that he drove by there the other day and the tree was still looking really good. There was one really large sycamore in particular that was pretty key to the project. And that one particular tree drew a lot of attention. And that one particular tree is still doing very well, which is good to hear. So I wanted to throw in a different example of what ground penetrating radar can do. This is a site in DC where the yellow line represents a proposed development site. The yellow line is kind of the property line. And currently it's a parking lot, and our client wants to build something. I'm not even sure what the proposed is, if it's mixed use or residential, but basically they want to build a big building, and it's a parking lot now. But there are these two trees that are not even on his property, but because they are so large, they are above the heritage tree threshold in DC, so they are protected by the city's regulation. So even though this property owner doesn't own these trees, he's still required to design around them and make sure that he can protect them during construction, or he will not be allowed to build on his site. So here comes the radar unit again, where we weren't really able to access the site to dig it up with an air tool and map individual routes. And frankly, it was a fairly large site anyway. Digging it up with an air tool would have been a pretty colossal effort. The radar unit was able to scan both trees over a fairly large area of the site in less than a day. So you can see the large sycamore tree there behind the fence on the neighboring property, and you can see the white markings in the pavement is how we laid out the scan lines. And then the willow oak that was the street tree, and you can see the sidewalk and the fence. And we ran straight line scans in front of that. And you can see how the scan layout looked, where we ran arcs for the sycamore and lines for the willow oak. And we actually ran, there's two different antennas that we have for our radar unit. The 900 megahertz antenna is capable of getting reflections down to about 36 inches, and it can reflect off and get a signal back from roots as small as a quarter inch. The 400 megahertz antenna can see and get a reflection back from almost 12 feet in depth, but it can only see roots half to 1 inch and larger. So if we're looking for deep roots or large roots, the 400 is a good option. On this site, we really weren't sure what we were going to find. On an urban site like this, like I said, this is in DC, who knows what kind of activity has gone on this site over the years. We didn't know what was going to be down there. So we actually used both antennas and scanned over all of the scan lines twice. We did them all with the 900 and then did them all again with the 400 so that we had double data. And this is just one of the examples this was the results from the 900 on the arc scans for the sycamore tree. And you can see the root detections at the different depth zones that we identified in the software. So I think our depth zones were 0 to 12 inches, 12 to 24, and then 24 to 36 for the 900 antenna. And you can see that there were an awful lot of roots in the top foot. There were a few roots in the second foot and almost no roots below 2 feet. Interestingly, you can see, I keep wanting to just walk over to the screen, but if you can see the white marks there and in here, this is a root density graphic. So the colder the colors, the blue colors are less roots, and the warmer the colors, more roots. But you can see that area that's white. There were actually no roots detected in that location at any depth. And it actually turned out that, so this is the final composite root density graphic overlaid on the survey. The intent with this was to give the designer and the owner some information about how to design around the tree. So we were able to pretty clearly show that there's areas where there's a lot of roots, those, you know, reds and yellows. And then there's an area where there's only a few roots, and there's actually a couple areas where there's no roots. So the areas where there's less or no roots are the areas where they're going to design their footing structures, their piers, to support the structure. They will use this to design the structure around this tree and build the structure up on piers, just like the other project. It turned out that my colleague that did the report for this project researched some historical fire maps, and it turned out that, insurance maps, it turned out that there had been a row house right where that, the area where there are no roots, that there had at one point been a structure there with a basement that had burned down and was backfilled. And that's why there were no roots there, or much less roots in that particular location. But this site was covered with pavement, and there were a lot of utilities and a lot of other things going on. It was a really difficult site to work. The air tool, when we go in there with the air tool and blast the tree roots, all the soil away from tree roots, it's really effective. We can see exactly what the tree roots are doing, but it's loud, it's messy, and it's really time consuming. So for us to go in and do a site like this, it would have taken many days. We would have had the site tied up for a long time. We would have been blowing dirt clouds everywhere. And you can imagine what doing that downtown DC would have been a non-starter. The radar was a really wonderful solution to that problem for this client. So there you can see the area where there's no roots. Am I going backwards? No, I am going backwards. There we go. So this was the other graphic that we can produce with this software that shows a predicted, I would call it a theoretical root morphology. This is not really a root map, but it does generate a graphic from the root detections, where each one of the root detections is connected algorithmically to generate this root map. But what's really interesting with this is in AutoCAD, which is the design software that the survey is brought into, we can create this root morphology map in 3D. So if our design team is trying to design, say, subsurface structures, utilities, things like that, we can actually take this in AutoCAD and lay it down and spin it around and look at it in 3D, just like we can with 3D surveys of the existing utilities, or a 3D model of the proposed utilities or structures or so on. So while it's not quite the same as an actual, we dug it up, we surveyed it, we know exactly, there is definitely a root there. This is a little more theoretical, but it's really, really helpful for a design team to visualize what tree roots are likely to be doing. And from a regulatory standpoint, it's really helpful to be able to point to something like this and say, hey, we're going to build a building here. We know these trees are here. We know we have to protect them. And here's what we've done to make sure that our design protects them as best as possible, or minimizes the impact as best we possibly can. So that was the purpose of this, really, was not just to design around the trees, but also to take this to the regulators and say, here's our design, here's all of the information that we've compiled about the trees and their roots, and here's how our design and the trees and the roots all fit together in such a way that we're confident that the trees are going to survive this activity. This graphic is just a two-dimensional graphic that shows the root density versus the actual 3D model. But it's really cool technology, and I like to talk about it. So with that, we've blasted through this quicker than I expected to. So I'm kind of hopeful that maybe there's some more questions. In the past, we must have bantered more. Well, that's the other thing. Oh, see, I haven't even gotten through one cup of coffee yet. So anyway, any questions?
Cary is finished with his presentation.
They're going. We already know. They came highly recommended from the tour. Oh, Philip, I don't know nothing. And it takes off a mission.
Okay, we've got one here at least. Mm-hmm.
Goes out to a certain area. But when he pulls down those trees, of course, he's dragging the roots. He's talking all those trees on those.
Yeah.
So how do you apply all this stuff?
Well,
Does it filter down?
you know, so the question was, and I think maybe twofold. One is when, and correct me if I missed the point here, but I think there's two questions in there. One question is, I talked about a bunch of sort of high-tech fun stuff that we can do when the client has, or the owner has the time, the money, and the desire to save trees. And sometimes, you know, we like to use the term Gucci garage. You know, we joke about it that, you know, hey, we found a client that wants to build a Gucci garage. He's going to build a garage, but he's got two big trees in his backyard, and he wants the garage right between them. Money is no object. The garage has to go there, and the trees have to stay no matter what. Figure it out.
Emily,
Those are fun projects.
can you hear me?
You know, the guy's got an open checkbook, and we can do whatever we need to try to save those trees. The flip side is, you know, very often we deal with regulatory type projects where, you know, maybe the owner cares a little bit about trees, but trees are not the highest thing on his priority list, and he's got a limited budget. So we have to balance the efforts to save trees with all of the other construction problems and budgets. So what we would do is look for the trees that are the most desirable on the site, and we would look then at how we could design around those with the minimum amount of effort. So going back to the preservation measures, you know, at a minimum, fence, maybe root prune, probably mulch, and pick the ones that are, go for the low-hanging fruit. Hey, there's a nice tree over there and there's a nice tree over there. Let me spend a little bit of money and make sure that they will at least survive. I know I'm going to lose most of the rest, but at least I've got those. So that's one approach. And I was going to look quick if I can find a couple of examples. I can show you some examples of some projects and sort of how we deal with the question of what I would call almost scope creep. Hey, why did that go over there? Come back over here. So scope creep, when the contractor goes in and starts digging, they're going to, okay, well, I know I have to take this tree down because it's in the driveway, and I have to take that tree down because it's in the garage. But in the process, I'm going to muck up the roots of that tree. Oh, well, so I might as well go take that one down. And then I take that tree down, and then I've got to, I damaged that tree. Well, now I got to take, so that you get this snowball effect. So we have kind of a way that we deal with that. And I'll try to find an example quick, and I can show you sort of how we treat things a little differently. Was there another question?
Why is it?
The question is that people still don't understand why the trees in the DC one where all that pavement was getting moisture. And one of the other participants suggested it was like a pot on its side where the water could just go under. But then the person who asked the question said, I'm asking because it seems as though one can make the case for paving over an awful lot of tree roots.
Well, you know what, and something occurred to me about that. The DC site in particular is a good example. When I say that it was pavement, yes, it was paved, but no, it was not I-66. It had been cobbled together and paved in bits and pieces over a long time. The pavement was broken in a lot of areas. There were patches of gravel and broken pavement. So the DC site in particular, there was a lot of opportunity for water to infiltrate. Sure, there were areas that were solid pavement. There were actually a couple of patches of concrete. But on the whole, I would say easily 80% of that parking lot was more porous than not, would be how I would describe it. Now, the site in New Haven, that was the other thing that occurred to me as we were talking about this. The site in New Haven, that street had been there since the 1800s. It was originally made of brick. So that original brick street is still there. And they've just paved over top of it year after year after year. It's probable that some moisture has got to get down through that. There's got to be cracks where the pavement meets the curb, for example. Water in a heavy storm is going to run to the curb and then run along the curb and go in an inlet. But in some portion of that moisture is going to make it into that crack and down below the curb. The other thing that happens is underneath hardscape, like sidewalks and pavement, is you actually end up with a fair amount of moisture that condenses on the bottom of the pavement that comes out of the soil under it, which is actually part of what the problem is with tree roots and sidewalks. Because you get condensation on the bottom of the concrete sidewalk, they design the sidewalk on stone so that that moisture can then drain away. But the sidewalk itself is still capturing that condensed moisture. So you end up with trees putting their roots right up against the bottom of the sidewalk because that's where the moisture is. So in those conditions, it's hard to say exactly where the water is coming from. Like I said, there's probably a lot of ways that trees are getting roots down into old sewers and storm drains and finding those places where the water is going. The water's got to be there and it's got to be going somewhere. The trees obviously are finding it. We just don't know how. The idea that we can pave over the tree's roots entirely is just not realistic, but you can pave over portions if you do it correctly.
So the question also was then, well, what about the oxygen? It's the same answer?
Well, again, the DC site had a lot of open space in that parking lot. But again, we had a willow oak and a sycamore tree. So back to those bottomland species that are more tolerant of low oxygen conditions. Yeah, and I mean, in a site like New Haven, most of the gutter downspouts would have connected at least indirectly to the curb, but there's got to be moisture getting down in there. There has to be. Now, again, you know, how the trees are finding those roots, you wouldn't know for sure, but obviously they are.
It's another question. Whether was this presentation ever given at the Waynesboro Tree Workshop?
No. Sorry, I'm looking for an example.
Deciding on trees to protect, and then there are others around that you know you're going to shut them down before construction, or you just leave them alone and cut them down later?
That is a fabulous question, and I'm going to answer that. Doggone it. I thought this plan had an example on it, but it doesn't. So there's a couple of things that are depicted on this plan. And one, well, okay, so let me go back to the question is whether or not you remove trees proactively if you know they're going to be impacted. And so the answer is yes. And what I would do, and that's, again, what I was trying to find an example that showed it. I have to find a different one that shows it. But what we try to do is, this one has it. Let me pull this one up. So you can see on this plan that there's two different symbols for tree removal. We know that if we root prune too close to a tree, it's not going to survive. Normally, the root pruning is depicted or dictated by the limits of disturbance on the construction project. So here's an example where we show tree protection fence and root pruning along the limits of disturbance. So that's the line in the sand that the engineer has given me and said, okay, our construction is on this side of the line, your tree save area is on that side of the line, that's the line in the sand. Our construction activity will not cross this line. Fortunately, that limits of disturbance, limits of construction concept, LOD we call it, is dictated by a lot of the erosion control requirements. So this is a typical part of the development design process. Engineers are used to this. So when we come in and do tree preservation plan, we say, okay, I need your erosion control plan because I need to see your limits of disturbance. And then I would use that limits of disturbance to help me understand what the impacts to the trees are. So here is an example of trees that are inside the limits of disturbance. We know this tree is going to get lost. These trees over here are inside a parking lot. There's no hope of saving those. And then we've got, these trees over here that are inside the area where he needs to grade. He's got, I think that's a fill over there. And then there's this tree that's just outside the limits of disturbance. It's not being removed directly by the bulldozer. But we as arborists know that that tree is not going to survive construction. So we design into the plan this concept of removal by arborist is the term that we came up with, just to demonstrate that it's different from a typical tree removal. And we put in a set of specifications on the plan that will tell the contractor standard removals mean this, this, this. Removal by arborist means that these are trees where the stump doesn't come out of the ground. These are trees that we know are not going to survive construction. We are proactively removing them because we know they're being impacted. Want the contractor, because then he's going to start impacting the tree behind it and so on. And then you get that snowball effect. So we designate these trees as removal by arborist. The specifications say that the tree needs to be removed by a qualified professional. It needs to be removed in such a manner so as to not cause any damage to the surrounding trees that are being preserved. The stump is to remain, or if the circumstances are, it may be that we designate that the stump gets ground out by an arborist and not excavated by a big piece of yellow equipment. So this is a tree by tree condition. We go around the plan and we decide, okay, here's trees. So here's an example of these trees are not impacted by construction, but they're declining. They're in poor condition. They're not in a safe place where we can just leave them standing dead. So they need to be removed for safety reasons out of this tree save area. Well, they also have to be designated as a removal by arborist because we don't want the contractor just taking his backhoe back there and pushing them over. So we designate specifically how they're to be handled. And the other thing that we do, if you see on this plan that the trees are color coded, when we do our inventories, hey, where did my cursor go? This is really awkward working. So we do our inventories for these projects. I don't show the title block. The inventory includes basic information about the tree, species, diameter, condition, but we also include a preservation priority. And for us, we use a 1 to 4 rating normally, where trees that are high priority for preservation are maybe trees that are absolutely excellent specimen quality, highly desirable species. Or maybe they're a tree that has some unique cultural value. I've worked on projects where there was a whole row of really crummy red maples that were beat up by snow plows and looked terrible, but they were the community's trees. They planted one there every year as a community. They did that. So there was a little plaque on every one of them. Even though the trees were in poor condition, and my initial reaction in the design was they're junk, nuke them. Let's put back something that's going to be nice. They said, no. Those are our community trees. Every one of them has a plaque and there's names and all of this ceremony every year. They matter to us. So even though they were junky red maples in poor condition, we designed our project to preserve them because they were a high priority for preservation for the the community and the owner. The other thing might be a unique species. Around here, maybe you got a bur oak, for example. We don't see very many of those. If you've got a bur oak in good condition, I would say that's probably a high priority for preservation. The flip side of that is trees in poor condition, critical condition, or trees that are not typically recommended for preservation might be, like I said, trees in poor or critical condition. I don't want to spend money and design my project around a tree that's in really terrible condition and is not likely to survive the project. Or if it does survive, it's got a big cavity and it's prone, you know, maybe it's got such a big cavity that I'm worried about the risk of failure. And now I built a house under it. Well, that's not good use of my effort, right? I don't want to spend money to preserve a tree that's going to be a threat to my house. Or maybe it's an ailanthus tree that's in really, really good condition, but it's an ailanthus tree and it deserves to die. So that's why we have these different ratings. So the green trees, priority 2, we would call it, those are trees that are desirable species. They're in fair to good condition. They're worth spending a little bit money on, but they're not uniquely valuable. You know, that one over there is no different from that one over there, and they're all decent. Let's save what we can. The low priority for preservation, we would call that a priority 3. Those are the less desirable species, maybe not invasive species that really should be removed, but they're just not the greatest tree to have right next to my house. I'm not going to spend any money to save it, but if they're over there on the back 40, I'm not going to spend any money to take it out either. Leave well enough alone. I'm just not going to spend any money. I'm not going to spend any effort to try to save it. If it's in the way, we take it out. Nobody's going to miss it, move on. But we do this as a part of the design process. You look at a site like this one where, you know, there's a lot of trees. Yo, come back here. So, you know, there's a lot of trees on this site. And when we were designing the utility connections, we had a little bit of freedom of, oh, can we mush the utility to the left a little and maybe save this tree? Or, you know, maybe can we move the parking lot a little to the left and save this one? And so on. But having that priority rating on the plans as an initial design step is really helpful, especially, this is not a great example because this site was already partially developed and they were kind of constrained. But if you picture a large site that's fully wooded and, okay, I'm going to build my building and I'm going to build my parking lot and here's my plan. And we color code the trees. The priority 1 trees are blue. The priority 2 trees are green. The reds and the oranges are the ones that I'm not going to worry about too much. The blues and the greens are the ones I'm going to try to focus on saving. So if we give the design team a preliminary plan that shows all the blues and greens and reds and yellows, or reds and oranges, that gives them one layer in their design to say, oh, well, you know, we were going to put our parking lot here, but I see there's a bunch of blue trees here. And we were going to put our park, you know, open space area over here, but I see there's a lot of red trees over there. Come to find out, well, that red trees is a grove of ailanthus, and the blue trees was a patch of oak trees, you know, and so now the designer says, oh, well, we can just flip flop our design. That's no big deal. That's not going to matter. We'll put our parking lot over here where the ailanthus trees are, and we'll put our open space over here where the blue trees are. The end result is a much, much better viable project in the end. All right, I got completely off on a tangent there, I think, but so I hope I answered your question. Did we have any more questions? Well, so one of the other pieces to your question was, you know, what does an average homeowner do? You know, some of this kind of activity can be done even on a small scale, on a new home or something small like an addition or a garage that you're going to build on your property, if you take the time to, think through it a little bit and give the contractor boundaries and say, okay, look, what do you really need? Yeah, I know you want 40 feet to work in every direction, but I've also got some trees that I want to try to save. How much space do you really need? We try not to design these projects with such tight constraints that it becomes impossible or really impractical for a contractor to construct it. There's always a balance between, yeah, you could send an army of laborers in there with shovels and have them do it by hand, or the contractor can take in a modest piece of equipment and have a little more impact, or the contractor can go in with the biggest piece of machinery he wants and have a big impact. And it's all about cost. That big piece of equipment might only take a day to do that excavation, but the result might be a lot more tree removal. Whereas, okay, we do it with a small machine, it's going to take 4 days, but we're minimizing the tree removal. Or these trees might as well be made of gold. We have to save them at all costs. We're going to go in with an army of laborers with shovels and do the work by hand. Those are our choices. So, back to the homeowner type situation where you've got a proposed garage, say, you need to define your priorities. Is the garage going to be a Gucci garage where, hey, this is the oak tree that had my grandpa's, rope swing in, and, I have to save this tree at all costs. Maybe you move the garage, unless you can afford to have that Gucci garage, right? So, you have to make those priorities known to the team and the contractor, and everybody needs to be made clear what the goals are, what the priorities are. But then, like I said, give the contractor the line in the sand. At a minimum, put up a fence of some kind. If there's trees that matter, use the critical root zone and the structural root zone formulas to figure out how much space you need to preserve around a tree and put up a fence and make sure the contractor understands what that fence means. Build it into their contract. You have the ability to do those kinds of things at minimal cost. With a little bit of effort, you can minimize the impact to the surroundings. Yeah, so the question was the situations that I would call removal by arborist. This is another good example here where, this tree is right next to the fence. We know that tree is not going to survive the activity, but that's where you would want to proactively remove that tree, but do it in such a way that you're not removing the stump. You would cut it down with a chainsaw, or maybe have to hire an arborist and remove it sectionally where it's, climbed or, what have you. But you have to draw that line in the sand and then determine which trees the contractor is allowed to remove his way with the big piece of yellow stuff, or the arborist way with a chainsaw, or the trees that are being protected truly. And, so this picture shows sort of all three. You've got 815 that's in the middle of the storm drain and is obviously going to have to be removed. It's going to be in the middle of the storm drain excavation, so the stump is going to have to be removed. The contractor is going to push that tree over with a big piece of yellow equipment. Tree 895 is going to get beat up so much that it's not going to survive. We know it needs to be removed, but if we remove it with a big piece of yellow equipment, then we're going to start impacting 896 and 897. But we can't do that. We want to save those trees. So we designate that tree as a tree to be removed by an arborist where it's cut down sectionally, removed in such a way so that it doesn't impact those other trees, doesn't cause any additional root damage, and we leave the stump in the ground. All right. Did we beat the horse?
Thank you very much.
All right.
Okay, so we're going to end the Zoom meeting. Thank you all for attending.
Thank you.
Thank you.
Bye-bye.
Bye-bye.